Good morning, grade 7s, and welcome to your Tuesday the 14th online mathematics lesson with WorksheetCloud. I hope you guys had a great Easter and got spoiled by the Easter Bunny. Okay, let's get on with today's schedule. Just before I continue, there's an email address on your screen. Please feel free to use it and send me any questions or related queries to any of the lessons that we've done. I'll be more than happy to answer them during the next lesson. So yeah, that service is for you to use. And on this website that you're accessing this pre-recorded lesson on, you will find additional activities for you to practice. So feel free to download those along with the memos to consolidate any information that you've learned today. Okay, so today we have your normal warm-ups and mental questions. And then today we're going to focus on the multiplication of fractions, and I'm hopefully going to show you a new way to make visual representations of the multiplication of fractions. And then we have a finisher, and I've got a new game to introduce to you today called Ken Ken, and then that's at the end. Okay, so your warm-up activity for today, you should know by now that you need to find the value of the symbols, and then don't forget the question mark right at the end. I would suggest that you press pause round about now, as I'm going to start working it out, and if you don't press pause, then you're going to hear all the answers. So I'd encourage you to press pause, work through it by yourself. Don't worry about how long it takes you. I'm not running away anywhere. I'll be right there when you press play again. Okay, so hopefully you've gone and you've worked it out. Let's see how you guys have fared. So we're more than likely going to start on the third line. Oopsie, hang on. On the third line, because we know that the telephone and the bowling ball and 10 pin are equal. So that means that 27 is going to be equal to 9 plus 9 plus another 9. Okay, so knowing that the telephone equals 9, then that needs to be 9 minus 5 is equal to 4. Okay, so the recycling is 4. So what do I add to 4 to get to 24? And both those values need to be the same. So yes, you are quite correct in saying it's 10. That is equal to the 24. Okay, and then right at the bottom, we're going to have 10 times 4 multiplied by 9. Okay, and then I think the cutout might be interfering there, multiplied by another 9. Okay, so how am I going to do 10 multiplied by 4 multiplied by 9 multiplied by 9? So just remember, it doesn't matter what order you multiply in, and I'm just going to clear a bit of space at the top here so I can do that. So how am I going to do the 10 multiplied by 9 multiplied by 9 multiplied by 4? So I can go 10 times 4 is 40. And then the 40 times the 9 is 360, and then the 360 times the 9, I can go the 300 times the 9 is 2,700, the 60 times the 9 is 540, and add them together. You can go 10 times 9 is 90, 90 times 4 is 360, and then 360 times 9. So what I'm trying to get at is it doesn't matter what order you multiply in, as long as it makes sense to you, and your answer that you should be getting is 3,240. Okay, well then, if you guys got that, and if you press paused and you struggled through it, even better. Remember, it's not always that you get these puzzles the first time around. They're designed to get you to work through and to struggle through a problem. Okay, your mental maths activities for the day. You need to write 42 as a product of its prime factors. Choose the method you would like to use, either the ladder or the factor tree method. You need to add some fractions with different denominators. I'd like you to complete that sequence, and if you can name that sequence, it's got a special name, then that would be great. Is 15,436 divisible by 4? So let's see if you remember the divisibility rules, and list the first 10 square numbers. Again, a great time for you to pause and go through those questions by yourself. Okay, so well done if you have worked through those 5 questions. Here goes the first one. Write 42 as a product of its prime numbers. So I'm going to use the ladder method. So what is my lowest prime number that goes into 42? That's going to be 2. Okay, that's going to go in 21 times. Okay, so 7 is going to go in there 3 times. And 3 will go in there once. Okay, so to write that as a product of its primes, we'll write 2 times 3, which is 6, times the 7 equals your 42. Okay, if you had done the factor tree method, you would have ended up with 2 times 3 times 7 as well. Okay, let's clean that and get on to the second question, which is just a recap of addition of fractions. Remember, when you add and subtract fractions, your denominators need to be the same. So what you should be saying is, what is the lowest common multiple of 5 and 6? Okay, and if you go through the 5 times table and you go through the 6 times table, you'll see that the lowest number that occurs in both sets is 30. Okay, so if I've got 4 over 5 and 7 over 6, which yes is improper, and my lowest common multiple is 30. So how did I get from 5 to 30? I multiplied by 6, so I must multiply the 4 by 6, so that gives me 24. Okay, how did I get from 6 to 30? I multiplied by 5, so I must multiply the 7 by 5, and that gives me 35. Okay, and if I add those together, I get 59 over 30, and that there is your answer. Okay, if the question had said convert that to a mixed number, then you would have just said 59 divided by 30, and that's 1, and I'm left with 29 over 30. Okay, your next question said complete the following sequence. All right, and then I asked you if you could name that sequence. Okay, so what's happening each time when I go from, let me just wait for that to clean. I go from 1 to 3, 3 to 6, 6 to 10. So hopefully you've noticed that the difference is increasing by 1 each time. So from 1 to 3, there's a difference of 2, or it's increasing by 2. Then we go to 6, it's increasing by 3. When we go to 10, it's increasing by 4. Okay, so then we'd increase by 5, then by 6 to get to 21, and then by 7 to get to 28. Okay. Question 4 is 15,436 divisible by 4. So the divisibility rule for 4 is if the last 2 numbers are divisible by 4, then the whole number is divisible by 4. And remember, that's because we know that 4 goes into 100 perfectly, which means it then goes into 1,000 perfectly. Okay, so can 36 be divided by 4? Yes, it can. 4 goes into 36 9 times. So therefore, 15,436 is divisible by 4. And your last question, question 5, list the first 10 square numbers. Remember, a square number is the answer you get when you multiply a number by itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Then 4 times 4 is 16. 25 for 5 times 5. 36 for 6 times 6. 49. For 7 squared, 8 squared, 64. 9 squared is 81. And 10 squared is 100. Okay, well done if you got those, guys, and if you remembered the principles that we had spoken about before. Okay, so today we're going to have a look at the multiplication of fractions. Okay, and it's different to addition and subtraction in that the denominators do not need to be the same. Okay, so as you can see with the example at the top of the page, a third times 2/5. All we're doing is we're multiplying the numerators together. 1 times 2 is 2. And we're multiplying the denominators together. 3 times 5 is 15. And that is it, guys. That is how you multiply fractions. Okay? You will need to simplify at the end, but we've spoken about simplification before, where we just look for the highest common factor that goes into both the numerator and the denominator. Okay, so I'm going to do the first 3 for you, or with you, should I say, and then I'll give you an opportunity to do D to R. Okay, so here we just, on A, we're going to say 9 times 5 is 45. Okay, so there's your 45 from 9 times 5, and then the denominator, 10 times 9 is 90. Okay, and if I asked you to simplify that, you should recognize that 45 is half of 90, so that answer simplified is 1/2. Okay, B, I'm saying 1 times 4 is 4, over 2 times 5 is 10, and then to simplify that, we look for the highest common factor of 4 and 10, which is 2. 2 goes into 4 twice and into 10 5 times, so the simplified fraction there is 2/5. And with C, 2 times 9 is 18, and 3 times 13 is 39. And both 18 and 39 are divisible by 3. So 3 goes into 18 6 times, and 3 goes into 39 13 times. So that would be your simplified fraction for 8 over 39. Okay, guys, this is a good time to press pause and to go over or attempt to do D, E, F, G, H, I. I'm going to carry on. So pause now, work through them, and then press play to see how you fared. Okay, so you'll notice that for DEF, the word of appears between the two fractions. So 1/3 of 6/7. Okay, so of, when we're dealing with fractions, tells you that you need to multiply. Okay, so that's just, you might be asking why they're now using of. So if I say to you, what's 1/2 of the 10 apples that are in the box? Okay, I'm not going to say what's 1/2 times the 10 apples in the box. We use the word of. Okay, but you still multiply. So nothing changes. I multiply 1 and 6 together and I get 6. And then I multiply the 3 and the 7 together and I get 21. And you can simplify that because 3 goes into both 6 and 21. So your answer there, 3 goes into 6 twice and into 21 7 times. So 2 over 7. For E, 1 times 4 is 4. Over 4 times 15 is 60. Okay, and 4 goes into 4 once and into 60 15 times, so 1 over 15 is your answer. For F, 2 times 6 is 12, over the 3 times the 7 is 21, and again 3 goes into 12 and 21, 3 goes into 12 4 times, and into 21 7 times. Okay. Then G, we go back to straightforward multiplication sign. So that is 28 over 40. Okay. Now, if you can't find the highest common factor of 28 and 40, there's no need to panic. All right. You can recognize that both numbers are even numbers. So 2 goes into 28 14 times and into 40 20 times. But then you should be able to recognize, okay, 2 goes into there again, so 7 over 10. Okay, so if you couldn't recognize that 4 was the highest common factor, then just divide by 2, and if it's even again, divide by 2 again. Okay, that's not a problem. It gets you to the same answer. Here for H, we've got 1 times 2 is 2, over 2 times 5 is 10, So that is equal to 1/5. Okay. And for R, 6 times 7 is 42. And that's going to go over 5 times 12, 15 times 12, sorry. How am I going to do 15 times 12? Well, you've got options. I could double the 15 to 30 and halve the 6 to 12. 30 times 6 is 180. I could say 15 times 10 is 115, and then the 15 times 2 is 30. Add them together, still gets me to 180. Okay, and then to simplify that, I'm just going to make some space. Okay, to simplify that fraction, I'm going to show you that, oh dear, I don't know what the highest common factor of 42 and 180 is. So what am I going to do? Okay, first I'm going to divide by 2. And I'm going to divide by 2 over here at the denominator. Okay, but then I'm going to recognize, okay, 3 can go into 21 7 times, and 3 can go into 90 30 times. All right, so if you had divided by 2 and then by 3, that's great. It's the same as dividing by 6. So 42 divided by 6 would have got you to 7 over 30. However, if you couldn't figure out that 6, then you can divide by 2 and then go and divide by 3. That's not a problem. Okay, well done if you got those. Let's move on to let's draw it. So I've always believed that it's a very good idea to represent mathematics visually. For some learners, this makes it a lot easier to understand. So I'm going to show you this method, which some of you may not have seen before. So what I've done here is I have drawn a set of blocks based on what the denominators are equal to. Okay, so if I multiply 5 times 4 for A, then you'll notice I've got 20 blocks because 5 times 4 is 20. Okay, so 1/5, if I colored in 1/5 of the 5 rows, I'm going to be coloring in that top row over there. Okay, because you can see that it's divided into 5 rows. So I'm coloring in one of those rows because it says 1/5. Okay, then I need to color in 3/4, and I'll do that in a different color. Okay, and you can see that the columns, so remember that rows go across and columns go down. So the columns, 3 of them need to be shaded. So I'm shading that one, the second one, and the third one. And now my question to you is, how many blocks have been shaded by both the blue and the red? And that is indeed 3. Okay, and over 20. Okay, so when you shade those blocks in, whichever blocks have, or however many blocks have been shaded by both colors, that is what your numerator is going to be equal to. Now we can have a look and say 1 times 3 is 3 and 5 times 4 is 20. So we know we must be right with the shading in. I'm going to do B for you. And then I'm going to let you get on with C and D by yourselves. Okay, so for B, let's get a different color. Okay, so I've divided into rows and columns. So I've got 3 rows. So that's divided into thirds. I need to color in 2 of those 3 rows. So there I color in the top one. I color in the middle one. Okay, so that's 2/3. And then if I look at 4 over 7, okay, the columns, there are 7 columns. Okay, 7 vertical columns. I now need to color in 4 of them. 1, 2, 3, and 4. Okay, and if I count the number of blocks that have been shaded by both green and yellow, or green and orange, you should count that there are 8. And my denominator is 21 because there are 21 blocks. Do I check? Yes, I do. My numerators multiplied together is 2 times 4 is 8. And my denominators multiplied together is 3 times 7, which is 21. Okay, guys, pause now. Try do C and D by yourselves. I'm going to continue it so you have your answers. But yeah, I encourage you guys to pause right now. Okay, I'm going to carry on. Hopefully you guys have figured out C and D. Let's have a look. So it's 4/5 of 4/5. So we have a 5 by 5 grid. So 25 blocks. So I need to color in 4 of these rows because it's 4/5 and the rows, there are 5 rows. So I'm coloring in 4 of the 5 rows. Okay, I'm going to go to yellow. And now I need to color in 4 of the 5 vertical columns. Okay, and now I need to count how many blocks have been shaded in. Okay, now if you count up those blocks, you should count 16 blocks have been shaded by both red and orange. All right, so my numerator is then 16. And my denominator is however many small squares there are. And we know it's 5 times 5 is 25. So quite a nice visual representation there, I feel. And then the last one, we have 2/5. Okay, so you can see that there are 5 rows. Okay, and 2 of those 5 rows are colored in. So that's the top row and the second row. And then we've got 3/8, and the 3/8, the 8s are divided up into the vertical columns, and I need to shade in 3 of those. Okay, how many blocks have been shaded by both green and blue? So you're quite correct if you've calculated 6. Okay, so my numerator is 6. How many blocks are there? There are 40 blocks. 5 times 8, which are the 2 denominators, is equal to 40. And there's my answer, 6/40. To simplify 6/40, we can recognize that 2 goes into 6 3 times and into 40 20 times. Okay, so perhaps that's something new for you guys, making visual representations of multiplication of fractions. Hopefully it helped some of you guys. Let me know by email what you think. Okay, right, so that's your finisher for today. But before we get on to it, there is the grade 7 at WorksheetCloud.com email that I'm talking about. Please feel free to use it. I'd love to get some of your feedback on how you're doing. So yeah, feel free to use it, and I will get back to you during the next lesson. So your finisher for today, again, it's a visual representation of a multiplication sum. So you need to tell me what the values of the milkshake, I think it's the strawberry milkshake, the love rainbow, the pizza, the love potion, and the coffee mug with the heart on it. Okay, so press pause, go ahead and work it out, and then press play and see if you can get the same answer that I'm going to work out right now. Okay, so if I redraw this grid quickly, okay, a bit of freehand. Right, so I'll fill in 7, 140. So straight away you should be saying to yourself, hey, what do I multiply 7 by to get to 140? And that's quite correct, it's 20. Okay, then this block over here is going to be the 7 times this 5. So that must be 35. Okay, and then I've got to figure out what this number is over here. Okay, and I must be honest and say that I did trial and error. And after a couple of goes, I realized that this was 10. Okay, so 10 times 20 is 200. And 10 times 5 is 50. Okay, now all that's left for me to do is either add vertically or horizontally. So if I add 140, I get 340. And if I add 50 and 35, I get 85. And if you add those together, you should get your 425, which is what we're looking for in the top left-hand corner. Okay, guys, well done if you worked that out. Right, so a new game that I'd like to share with you today is called Ken Ken, and I've included the website address on the screen for you to go and have a look at it. You get multiple different sizes, and you get different options where you can use only add or add and subtract or multiply, divide. It's very similar to Sudoku, but with just a little bit of a twist. So in a 4x4 grid like we've got on the screen, you can only use the numbers 1, 2, 3, and 4. Okay, so you'll see this yellow block up here is saying, hey, my answer needs to be 2. Okay, so I can only use the numbers 1, 2, 3, and 4 to get the answer of 2, but I have to subtract those numbers. So I might say 4 minus 2 is equal to 2. Okay, and here I might say 3 minus 1 is equal to 2. Right, now the key is you cannot have the same number repeated in a row or in a column. So over here I want to say 2 plus 1 is equal to 3. Okay, because that's the answer I'm looking for in, you can see the thickened black border around 2 and 1. Okay, I know I need to put 3 here because, well, only 3 can equal to 3. So now you can see in that column, the left-hand column, no number is repeated. Okay, so let's carry on. Right, I need to get an answer of 3 by subtracting. So I'll put 3 and 1. 3 minus 1 is 2. So I need to actually change that to 4. Okay, so below it I need to make an answer of 4. So I'm going to say 3 plus 1 is equal to 4. So are we good so far? Horizontally, no repeats. Vertically, no repeats. It doesn't matter if they repeats diagonally. Okay, we're only looking vertically and horizontally. Right, this is 2 because only 2 is equal to 2. And again, it looks like we are in a good place. Okay, here I'm going to say 4 minus 2. Do I have any repeats? So no repeats horizontally as of yet, and no repeats vertically as of yet. And then I need 7, so I'm going to say 4. Now I've already got a 4 there, so I can't say 4. The only number I don't have there is a 3 and 4 is 7. So guys, that's Ken Ken. All right, go onto that website, have a look at some of their grids. A 3x3 grid, you can only use the numbers 1, 2, and 3. A 5x5 grid, you can use the numbers 1, 2, 3, 4, 5. And just remember that you need to get the answer in the top right-hand corner and use the operation that's next to the answer that you need to get. I hope that makes sense. Perhaps if you go and play a few online, it might make it a little bit easier for you to understand. Right, guys, that's us for today. Thanks for joining the grade 7 maths class. Enjoy the rest of your day. Look on this exact same WorksheetCloud.com website for an additional practice activity on multiplying fractions. There is also a memo with those worksheets. And again, use the email address you can see at the bottom of your page to send me any queries that you may have. Thanks very much for joining. Keep safe and see you tomorrow. Cheers, guys.